And the problem is that depletion of glutathione as a substrate will lower glutaredoxin. It's also a molecule which uses glutathione, and decreased incorporation into the mitochondrial complex 1. So we have there two enzymes, mitochondrial complex 1 and aconitase, which is just the first enzyme in the Krebs cycle. It's basic biochemistry. I will highlight it a little bit. Do you remember this? The oxidative phosphorylation. Very simple, huh? 4 complexes, and here the best engine in the universe with the highest capacity, not much heat is lost. Here electrons are gathered from the Krebs cycle. They are transferred across mitochondrial complex 1. The UQ is ubiquinol, the coenzyme Q10, that carries the electrons which are gathered to complex 2 and 3. Protons are pumped out of the mitochondria, and lastly they come in, which can generate energy. That's how it should go. But I will argue and claim and prove that Parkinson's disease, of course it is a lack of dopamine in the substantia nigra, but the reason Parkinson's disease can develop is a problem in just this mitochondrial complex 1. Because this complex 1 is highly dependent on iron-sulfur clusters. What does that mean? New research from the last years is now diverting to this kind of field, because the iron-sulfur clusters in our human system have not been examined totally yet. But it is just like Mother Earth, its core looks like. Because when lava, especially in this country, it's a country built on volcanic activity, but once somewhere in the ocean a lava comes up, an island is formed, it only takes a very short time before life itself is created on that island. No fish there, no animal there, but life, vegetation will just start to spring out, because it has a lot of iron and it has a lot of sulfur. And the core of our mitochondria, which are organelles of other origin than the human cell itself, it's a kind of bacteria in the human cell. It has its own DNA that also is dependent on these iron-sulfur clusters. And when you now know that aluminum is Al3+, and iron here is Fe3+, then you can imagine how aluminum can displace the iron from that molecule, and the complex is rendered inactive. And mercury, which has a very high binding capacity for sulfur, it binds 2 S's, the Sa, selenium, and the S, sulfur. And when you have a little aluminum and a little mercury, the iron-sulfur clusters are damaged. And it is almost for permanently, because mitochondria can regenerate, but if you don't remove the aluminum and the mercury from within the cells, a new mitochondria will just pick it up and also be destroyed in its function. So what do we need to replenish iron-sulfur clusters? We need cysteine. It's a precursor for these iron-sulfur clusters. Here you have 3 examples. The cubane form, which has 4 irons and 4 sulfurs, but you also have a cuboidal form with 3 irons and 4 sulfurs, and there is also a double iron, double sulfur cluster. And these, you just have to imagine, a little bit imagination, that when electrons are gathered from nutrition and are being burned, these free electrons will be guided through this field to the ubiquinol. Because when an electron is free, it is so highly energetic, it would destroy any molecule on its pathway. And it is these iron-sulfur clusters which protect us from that. But when they are damaged, you don't only have a lack of energy, but you have a lack of function of your complete cell. Because these iron-sulfur clusters are involved in 3 types of the 4. Types 1, 2, and 3. Here we have those same clusters, and now we get the vaccination. Oops, that's a little quick. Here we have ethyl mercury from vaccination, minute amounts. But ethyl mercury displaces the iron-sulfur cluster. So free iron is generated. And what does free iron do? Just leave a piece of free iron here or outside with water and air. What happens? The first thing, it starts to rust, so you get oxidation. Free iron in the human cell does the same. It generates tremendous amounts of free radicals. So the process is a vicious circle. The mercury binds to enzymes like glutathione peroxidase or the thioredoxin, which makes them inactive. And the mercury concentration from ethyl mercury outside the mitochondria compared to the concentration inside the mitochondria is a factor 5,600 times more. Because inside the mitochondria, there you have the sulfur and much of the selenium. Therefore, the mercury is transported. It's just chemical attractivity. But it's a factor first 5.6 and later a factor 1,000 times more potent. So therefore, you will not find it in blood. You can do any blood or hair mineral analysis, but you will not find it there because it's inside and deeply inside your cell organelles. But with the consequence that you will produce ever more free radicals, and as said before, mitochondrial dysfunction. I can claim that all chronic disease is a mitochondrial disease. Mitochondrial dysfunction, no energy, no repair, and you will have illness, chronic illness. Okay. So I would like to make a very short break. I prefer during the 4-hour lecture that we do 2 short breaks instead of 1 longer one, so you can gather your things together again, and then we continue with the lecture about Parkinson's disease.
Thank you, Raymond. 今ベーシックなお話だったんですけれども、何か、ご質問、この後ですね、まだ3時間ぐらい続きがありますので、今のうちに聞いておかないと質問を忘れてしまうと思いますので、何でもいいので、もちろん日本語で結構です。ご質問があればどうでしょうか。どうぞ先生、どうぞ。
すいません、先ほども言っているんですけれども、歯科で、ヨーロッパとかアメリカはアマルガムが非常に使われていると思うんですけれども、日本は保険が関係で金パラといって金銀パラジウム合金の方がよく使われています。で、そのことで何かありますか。
Do you understand? Okay. Do you know the palladium? It's the mixed metal. It's the in Japan. It's the
in Europe as well. Mm-hmm. They use it there as well, and it's not from me, but German physicists and medical doctors have examined palladium already in the 90s, and it is the more metals you combine together, the worse it gets. So crowns with palladium are even more detrimental than the mercury itself.
Oh, that's too bad.
Yes, but unfortunately, palladium cannot be measured. We have a machine which can measure currencies, just an electrical current around the teeth, and you put one electrode here and one on the other side, and a standard amalgam filling has about 14 millivolts. Mm-hmm. So when you have 10 fillings, you have 140 millivolts of electricity in your mouth. You could argue, well, what's 140 millivolts? But it is so much for a meridian that it is a constant activation or even blockage of a very important energetic pathway. And when we measure crowns, they go into the voltage range. They are 5 to 10 times in the electrical activity worse than the standard amalgam filling.
先生よろしいでしょうか、回答として。
The best thing for a dentist, of course, the patient cannot maybe afford it always, but the best thing to do, our biological dentists, we work with biological dentists who are very familiar with the whole concept. And when you use zirconium, that's one of the best. We rarely see patients having complaints from zircon. And a porcelain tooth, when you could make a porcelain tooth of that's also very much less active than. But palladium as a metal is just as toxic as mercury.
今金属のクラウンをお持ちの方はびっくりされてるかもしれませんが、アマルガム並みに危険なのではないかというのがレイモンド先生のご意見でした。他ご質問等は、どうぞ先生、マイクをお渡ししていただけますか。ちょっとお待ちください、今行きます。
藤原と言いますけど、先ほどの質問に関連して内科の方でこういう金属のチェックをするときにですね、口腔内の先ほどのガルバディ電流ですか、そういうのは日常的にチェックされることはあるんですよ。
レイモンド、OK.
You can translate now for me.
Yes. It's are you measuring some electrical change? Okay. Okay, yeah. Are you checking some electrical differences of the patient in your clinic? Is there some electrical, difference? The patient with crown or amalgam?
Yeah, we only measure the local environment. I cannot measure total electrical capacity of the body. I just measure locally. When you have a healthy tooth, you measure 0.01 or something like that. But when it's already an amalgam filling, it already starts to increase from 5 and some teeth 20 millivolts. So, and when you have crowns, it's even much higher. It's locally. It's not a total body measurement.
よろしいでしょうか、先生。
Thank you very much.
はい、ありました。その他。どうぞ、挙手をされた方のところにお願いします。
素晴らしい講演ありがとうございました。ちょっと英語で質問できなくて恥ずかしい恐縮なんですけど。
いえ、そんなここは日本ですから大丈夫ですね。
ちょっとカドミウムについてちょっと聞き漏らして確認したいんですが、先ほどかく乱物質でエストロゲンのアナログで、トリプルネガティブのその乳がんも増殖させるという話を伺ったんですが、その更年期症状に関してはどうなんておっしゃったかちょっと聞きたい、分からなくて。
Yes, one of the slides had postmenopausal women, and what happens is that their testosterone level is higher than in non-exposed women.
テストステロンが上がるわけですか。ということは更年期症状が増悪するということでよろしいんですよね。
Yes.
ありがとうございます。
不思議な現象だと思うんですけどね、そういう話です。では、5分の休憩ということでよろしい。Thank you, Raymond. We have a 5 minutes break. Okay.
では5分間休憩取らせていただきます。よろしくお願いします。